Hi, my name's Dan, and this video is part of a series that I'm doing on simulated logic series using software called Digital Works. In this short series, I'm creating binary decoders. And so far in the series, I've created a 1-bit, a 2-bit, a 3-bit, and a 4-bit decoder. And in this one, I'm going to talk about a thing called a decoder with enable. The wider context of what I'm doing is that I'm going from the principles of fundamental logic gates, and the long-term aim is to develop a simple CPU. Um, and if you follow through all the videos, you should see the whole process. There's a roadmap down in the description. Also in the description, there should be a link to where you can get hold of the digital work software that I'm using, which is free. This is simulation of digital circuits I'm using. So I said I was going to do a decoder with enable. And what that means is that a standard decoder takes a binary input and gives you an output uh, of one of a discrete number. And so with a 4-bit binary decoder, which we did in the last video, you've got 4 inputs, which gives you a potential of up to 16 binary numbers, and then you have 16 outputs, and which output is used depends on what your binary input is. However, sometimes you want something with a slight bit more sophistication, and that sophistication comes in that you want to select an output, but you don't necessarily want that output to be active all the time, and you might want to be sending a signal through that. Often that's a pulse or a single burst. Um, and so what you do is that you set up your which output's going to be used by using the decoder, but then you have a separate input, which is actually your signal input, or in this case, we're going to call it the enable input. So effectively, when the enable is yeah, okay, so another way of thinking about it, when your enable is low, then your decoder isn't working and you get no output at all. When your enable goes high, then your decoder actually gives you an output on the selected output. Um, and this is actually really quite straightforward. But all you need to do is to add something to the output from your decoder. And what we're going to do in this video is we're going to create a 4-bit binary decoder with enable. And we're going to use the 4-bit binary decoder that created in the previous video and just drag that in, and we're going to add to the output and enable. And the way to do that is for each of the outputs to add another AND gate and connect one of the inputs from it for the AND gate from the relevant output on our decoder here, and the other one to our enable line. Okay, so we're going to want 16 of these AND gates, but they only need to be 2 inputs, so we're going to move everything up a little bit and stick in a whole load more of these. 1, 2, 3, 4, 8, and highlight, copy, and paste, so we get 16. And we're going to need 4 inputs, so these are just going to translate straight into our inputs here on our macro. And then we're going to need another input, which gives us the enable. So that is going to be the enable input. What I'm going to do is I'm going to use the bottom input for each of these gates here. I'm going to do a little bit of tidying up. So that's a bit straighter. I'm going to connect each one of these up here. That could have been neater. Bottom one from each. And okay, so I will do the rest of that in a second, but also I want to connect the top one for each to a pin from here. So what order do I want them in? Oh, we've got 0 at this end, 1 at this end. We probably want 0 at the top. Sorry, to 15 at this end. 0 to 15. So we're probably best going with this kind of wiring configuration. So they're going from the tops across. So I've got 2 sets of wiring to do. So I'm going to speed up the video whilst you watch this. Obviously, if you're creating this, which you I would encourage you to do, then you might need to pause the video whilst you do it yourself. So there, I've done all the wiring up. I hope it's right. It certainly looks right. You'll have noticed that I've also added in the outputs that I didn't have before, and I've wired up the inputs as well. And I just need another couple of annotations in here, so that's going to be enable. And we're going to have inputs 3 to 0. Okay. That should be fairly obvious because we've linked into input 3 to 0 here on the macro for the 4-bit decoder. So next, as always, we need to set up the what it looks like as in the template editor. And because I'm doing this straight after I've done the standard 4-bit decoder, I've still got the same configuration in the template editor. I'm just going to add the enable in, just while I'm moving that across. Enable. So I tend to use a principle of 7 points for labeling inputs and output, labeling pins, and then 10 points for the actual name. And I'm going to call it 4-bit decoder with enable. So that's the enable input. And then we need to do the old tedious connecting pins together to the tabs. So once again, I'm going to speed up the video whilst I do this. Right, that's all the tags and the pins wired up, and so it's time to save this as a macro. Save as, I'm going to call it decoder 4-bit with enable. It should appear on my parts list. There we go. Okay, we're just going to do a proof of concept again to check that it's working. So new circuit, drag in the 4-bit decoder with a name. Come on, what's going on? There we go. That looks like a thing. We've got a few inputs to stick on. 1, 2, 3, 4, and enable, and then 16 inputs. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They're a bit more spread out than maybe I wanted them. But you'll see even the main circuit for this. I could have been neater, but on a testing circuit, as long as it's fairly clear what's going where, I don't really worry. So you can watch as I wire these things up. I'm not going to speed up at this point because there's not that much to do. But I feel like I need to say things at this point. So, how's your day going? You having a good day? I've got a bit of a cold. If I stopped looking at what I was doing, I could look over at the window and tell you that it's sunny outside. And yet here I am wiring up decoders. There we are. Right, let's give it a test. Make it run. And so at the moment, 0000, but enable isn't on. If it's hit enable, then that should, yes, it enables the one at the left hand end. Let's do 10. So I don't think the decoding is going to be wrong. I could go and test through each of these individually. And maybe I should, but I did test the actual 4-bit decoder, so it's just really testing the enable works. Let's just use them with a couple of random choices. 7, that seems probably about right. And 1. There we go, yes, fine. So that seems to be working. So that's it from me for now.